Hi everyone, Miss Shane here. This is lesson 4. We are still working on solving equations, but now I want to start talking about some special cases. Today I did not make a guided notes because it goes along really closely with what we did on lesson 3, and this should actually be pretty quick. But if you would like a piece of paper to take notes and a pen or a pencil, you will need your textbook again, either the physical copy or the online version. Algebra tiles and the equation mat are, again, optional. Our content and language objective are still the same for lesson 3. We're still working on evaluating possible solutions to multi-step equations and describing the steps used to solve the multi-step equations. We're still on page 339 in section 6.2.1, but now we are working on problem 6-51. All right, so 6-51 says Amelia wants to solve the equation shown on the equation mat at right. After she simplified each expression as much as possible, she was confused by the tiles that were left on the mat. So our first step is, what was Amelia's original equation? Okay, so I have laid out the tiles from the equation mat for problem 6-51 right here. Remember, blue is positive and red is negative. So on the left side, I have 2x plus negative x plus 1 plus negative 1 is equal to, on the right, x plus negative x plus 3 plus negative 3. If we remember our steps from lesson 3, our first step is to simplify both sides of the equation by combining like terms. So we're going to look at both expressions over here, both sides of the equal sign, and we're going to simplify each side one at a time by combining like terms. So on the left side, I see I have a positive x and a negative x and a positive and negative unit tile. These cancel each other out and can just go away. On the right side, I can also cancel out an x, but then I can also do the same with all 3 of my unit tiles. Now I have an x on the left side, but what about on the right? All right, I don't have anything over there. There's no value. So we say x is equal to 0. All right, so if we have the solution of x is equal to 0, this just means that if I were to substitute 0 for all of those x's in my original equation, I would end up with that. I see I have multiplication, subtraction, and addition, so I'll do my multiplication first. 2 times 0 is 0, and that's the only multiplication I have in the equation. But I want to draw your attention to these negative zeros right here. So normally, say if x were 2, then negative x would be equal to negative 2. But in this case, x is equal to 0, which means negative x is equal to negative 0. But we don't say negative 0 because 0 has no value, which means it can't be negative. So negative 0 is just equal to 0. So let's go ahead and change these negative zeros to zeros. All right, and then I am set to just add and subtract from left to right on both sides of the equal sign. So on the left, 0 plus 0 is 0. I still have my plus 1 plus negative 1. 0 plus 1 is 1, plus negative 1 gives me 0 for the left side. On the right side, I'll start with 0 plus 0, which is again 0. 0 plus 3 is 3. 3 plus negative 3 gives me a total of 0 again. All right, so this means that our solution of x is equal to 0 was correct. So the purpose of this was just to kind of show you that when you don't have any tiles on one side of the mat and you just have an x on the other side, it's completely valid to have x is equal to 0 as a solution. All right, so I just wanted to introduce you to a special case of x is equal to 0. Okay, so we have now lesson 3 and 4, we're both talking about solving equations. So be on the lookout for our next assignment, which is going to be an activity directed at lessons 3 and 4. So it's just going to be about finding solutions to equations or evaluating possible solutions. Remember, when I say to evaluate a possible solution, you just have to substitute whatever value for x I gave you to see if it makes both sides of the equal sign match up. So be on the lookout for that activity, and I will talk to you guys soon.